if we're working through the problems anyways.
Yeah, I
If
just
you're
have,
on the laptop, you can hit record on the bottom. There should be a button.
I,
Yeah, but
I
you
just
need
hit
a,
it.
it says you need a request from the meeting host.
I just hit record. We are recording this. This is
Okay, thank you.
officially recorded. I'll probably just throw up a YouTube page, and make a couple of different like playlist things on there, and throw this in like a chemistry playlist. Um, so we can just do that. Uh, but anyway, so I will do that. Yeah, my plan today is just kind of to run through some of those gas laws. Next week we'll talk about them a little bit more, but I kind of want to just go through the basics and answer some of those questions about how to do a couple of those things on like that worksheet. And so I'm going to go ahead and do a quick screen share. Maybe. There we go. Here we are. All right. And so here's that worksheet. And I really do like this worksheet. I've used this worksheet in several of my chemistry classes before, just because this first page does a really good job, I feel like, of laying them all out. Okay. And so we can kind of just run through some of these, and then I will work out on that whiteboard any ones that you guys specifically have questions on. All right. And so some of these, I think where some of you guys were running into problems is that we might not have been using the correct R at times. So you might have been using the one for kilopascals, and when you should have been using the one for atmospheres, or the one for torr, okay? Because there are several different ways that you can measure whatchamacallit, pressure, okay? So I believe that might have been one of the main things that you guys were running into. So we'll just work through those and double check some of those answers. Obviously, again, you'll have to bear with me. That whiteboard, as we remember from Tuesday, is not the greatest thing, especially trying to work it with a mouse pad. But are there any questions? Perfect. Okay. Well, then I guess I will just run through. So Boyle's law, all right. Boyle's law basically is just stating that as long as the mass of the gas is constant, if you increase the pressure, as long as mass and temperature are constant, pressure and volume are going to be pretty much linked together, okay? And so, let me see. I'm going to need to try and whiteboard this here. Let's go ahead and we'll just work one out for each one of these. I think that'll probably be easiest. Screen share, whiteboard. All right. And so we know that Boyle's law equals P1 V1 equals P2 V2. Okay, so we know that. Now, this pretty much means that everything has to remain equal. If we have our P1 V1, okay, and we increase pressure, what do you think will happen to the volume for V2? Anybody can answer.
Sorry, what?
So if you increase, so if you have your P1 and your V1, okay, your pressure and your volume at the beginning, and you increase pressure, so your P2 is higher than your P1, is your V2 going to be higher or lower than your V1?
Your volume should be lower because they vary inversely.
Yes, okay, so that means And we'll do a quick problem to check that. But yeah, essentially one will go up, one will go down, basically on how determined on how you do that. So let's go ahead and do, and in case anybody wants to do a different one, let me know. But I'll probably just roll with number 3. Okay, number 3. A sample of nitrogen gas has a volume of 478 cubic centimeters and a pressure of 104.1 kilopascals. What volume would the gas occupy at 88.2 kilopascals if the temperature remains constant? Okay, and it's important that the temperature remains constant. So we have our, okay, so P1 is going to be 104.1 kPa, okay? V1 is going to equal 478 centimeters cubed. I don't really know how to do the little caret thing on this. And then finally, you're going to have P2 is going to equal 88.2 kPa, kilopascals. V2, that's what we're trying to solve for, okay? Now, based on what Ethan just said and kind of what I talked about, since the pressure goes down, P2 is lower, will the volume, should the volume be higher or should the volume be lower for this? Should our V2 be higher or lower than our V1?
Lower.
Nope. And so the reason for that is our P2 is lower than our P1. So that means that our V2 will be higher than our V1 because they have to come out to be the same number, okay? And so basically, let's go ahead and work this out. And so we're going to have down here 104 point, somebody just asked a question. Cam said she'll be right back. Okay, Cam. 104.1 kPa. I'm going to put that for times 478 centimeters cubed is going to equal 88.2 kPa. Let me see if I can extend that box. Oh God, what just happened? There we go. No, I'd like to go back into that, but whatever. This is annoying, and I hate this. Sorry. This just isn't the greatest whiteboard thing in the world. Let's go ahead and do undo. There we go. Okay, so 104.1 kPa times 478 cm cubed is going to equal 88.2 kPa. Again, let's try and extend that box. Times V2. So all we have to do is solve for V2, right? Simple enough. So first thing, what I would probably do is just go ahead and multiply everything on the left side. So our 104, 1.41, or 104.1 times 478, okay? Now using our sig figs, how many sig figs should this have?
3.
3 sig figs, okay? And so this comes out to be 49,800, okay? So you're gonna have 49,800 And we won't put a thing on it yet, but just know that we will end up in centimeters cubed, okay? 400 equals 88.2 kPa times V2, okay? So once we've done that, what we are going to need to do is divide 49,800 by 88.2, okay? And once we do that, we will get our volume, our V2. So 49,800 divided by 88.2 kPa is going to equal V2. V2 is equal to, all right. Okay. 49800 divided by 88 divided by 88.2. Okay, so you should come out to 565, once you've rounded for sig figs, 565 centimeters cubed. Does that make sense? People see how I got that?
Yeah.
Yep.
Yes. Yep.
Are there
Yeah.
any questions right now about, is there any questions about anything? Are we good with Boyle's law? Basically, if you have your original one, so if you have your P1 and your V1, okay, if P2 is bigger than P1, then V2 will be smaller than V1, and vice versa. If P2 is smaller than P1, V2 will be bigger than V1. Okay, they're inversely things. So as one goes up, the other one goes down. Okay, does that make sense?
Yes.
Yeah.
Yeah, makes sense.
Sick. All right, let's go ahead and do another one. This time we will do one with, is it Charles' law that's next? Yes. So this is volume and temperature. Okay. Trying to find a good one. There's a good one. All right, so this is volume and temperature. Okay, I'm gonna go ahead and clear the whiteboard. Okay, so Charles' law is P1, no, V1 divided by T1 over V2 divided by T2, okay? Oh my God. All right, so V1 divided by T1 equals V2 divided by T2, okay? And so for number 4, you're gonna have your V1 is 8.98 decimeters cubed, okay? So let's go over here. V1 is going to equal 8.98 decimeters cubed. T1 is going to equal 30 something. God, this is much harder than trying to do it on a whiteboard. 38.8. Guess I'll do it there. 38.8 degrees Celsius. Yes. And then the T2 will be negative 39.9. Okay. Celsius. And then T2 going to equal negative 39.9 degrees Celsius. We want to find V2. Okay, so essentially how we're going to have to set this up is we're going to have 8.98 divided by 38.8, okay? And that's going to equal V2 divided by negative 39.9, okay? So we have those two numbers. Now, let's go ahead and figure out what this will be. Again, we should only have 3 sig figs due to 8.98 having only 3. So 8.98 divided by 39 or 38.8. Yes, 38.8 also only has 3 sig figs, so it doesn't really matter which one you use. Okay, so we'll have 0.231 is going to be equal to negative 39, or sorry, V2 divided by negative 39.9. Okay, so we're going to go ahead and have to figure this one out. Oh, and I forgot, you guys probably might have had trouble with this. Due to the fact that this negative 39 is constant, or is negative, that will make your answer negative, and you'd probably wonder how you got negative, whatchamacallit? Why can't I think of the word? Negative volume, right? Did anybody have questions about that? Why you have a negative volume there?
Because we didn't convert to Kelvin.
Yeah, sorry. I completely spaced that. You're going to want to convert these to Kelvin. So all you really have to do there, and I'll do those really fast. So 38.8 plus 273. So 311.8. Okay, and that's Kelvin. Sorry about this, totally spaced that. That is my bad. Okay, and then 273 minus. Okay, so this one will be 233.1. Kelvin. My bad about all that, guys. Just like you guys, my brain is not fully in school mode right now, but I'm trying to get it there. All right, so now I got to redo that in one number. So 8.98 divided by 311.8. Okay, and so you're going to have 0.0288. Okay, so we have, there we are. And then this will be 233.1 Kelvin. Okay, so then the next thing you're going to have to do is to multiply both sides by 233.1. All right, so you're going to have 0.0288 times 233.1 Kelvin is going to be equal to V2. Okay, so V2 is equal to whatever that comes out to be. So 0.0288 times 233.1. 6.71. decimeters cubed. Okay, does that make sense to everybody? Did everybody see how I worked through that? And again, sorry I didn't do that the first time. That is a rule that you should follow. I just kind of spaced it. You do want to make sure that you change your temperatures into Kelvin every time. Kelvin, you'll never work with negative temperatures if you do that, because you can't go lower than 0 degrees Kelvin. So that would be not only a recommendation, but it's kind of a rule to follow. And I just spaced it. That's my bad. And so we can see here that as the temperature decreases, volume will also decrease, okay? So you can kind of think of that like if you blow up a balloon, right? And you blow it up real big, and then you go stick that balloon inside of a fridge, what happens to that balloon?
It's smaller.
Yes, the volume goes down. The air starts to condense, okay, due to the fact that the temperature has gone down, all right? So is there any question about Charles' law? And might have to burn through a couple of these. Do you guys want to see, are there, I guess, because this has already taken a decent chunk of time, and I want to make sure we get through them. Are there any of these that you guys don't want me to do? Because I feel like the P1, Guy-Lussac law is probably pretty easy. Dalton's law is probably pretty easy. Are there any of these that you don't want me to go through, or do you want me to try and bust through all of these real fast?
I thought Avogadro's was pretty easy,
Yeah,
and
Avogadro's.
so was the ideal gas law.
Okay, so you thought the ideal gas law was easy?
It wasn't that bad, except I was mixing up N's.
So N
And
is
all
always
of
going to
those
be
have problems.
moles. Yeah.
Yeah.
N will always be moles. So is there, I guess is a better question, is there any of these laws that you want me to go through really fast? Any specific ones? Or is there any problems that you guys had problems with? Because I can, instead of wondering about laws, I guess I can ask about specific problems.
Can you go through the combined gas law?
Yeah, sure. And that would be P1, V1 over T. Okay. What is standard temperature pressure again? Not on here. Sword was on this list. Oh, give me 1 second. I always forget what standard temperature and pressure is. Chemistry.
1 atmosphere and 32 Celsius.
There we go. Standard temperature and pressure
Zero.
is, yeah. No, you mean 0 degrees Celsius.
Yeah, 0
32
Celsius,
Fahrenheit,
32 Fahrenheit, whatever.
Yeah, yep. All right. So we can do that one. That'll be number 8. I just always forget what STP is until I have to use it. So let's go ahead, or not number 8, number 5. So I'm going to go ahead and clear this now. Number 5, this is using the combined gas law. And this is P1 V1 divided by T1 equals P2 V2 P2 V2 divided by T2. Okay. So for number 5, we're going to have a sample of gas has a volume of 215 cubic centimeters. Okay, so we know that our V1 equals 215 cubic centimeters, cm cubed. It does give us our temperature at 235, or sorry, not 235, 23.5, but we can do 23.5 degrees Celsius plus 273, okay? And so our T1 will be 296.5. Okay, and then our pressure is going to be 84.6 kPa. Okay, so 84.6 kPa. All right, we know that at standard temperature and pressure, our temperature will be 273 Kelvin, and our pressure will be 1 atmosphere, and 1 atmosphere, if you convert that, is 101 kPa. Okay. All right, and so what we are going to look for is our V2. Okay, so down here, P1. So we're gonna have pressure 1, 84.6 kPa, times our V1, which is 215 centimeters cubed, cubic centimeters, divided by, and we put that all in parentheses just to make sure that you guys, all right, divided by our temperature 1, which is 296.5 degrees, or just Kelvin, is going to be equal to our P2, which is 101 kPa, times V2, which we don't know, okay? And then all of that is going to be divided by 273 Kelvin, okay? And so put these, nope, click up here.
Do you mean all of it or just the last part of it?
What are you talking?
Divided by 273. The 101 kPa?
Yes, so the 101 kPa divided by, or times V2 is divided by, that's why I put it in parentheses.
Oh, okay.
Because every, like just up, like it would be up here, P2 V2 is divided by T2, okay? And so it's all of this divided by this, okay? So the first thing that I think we should do is solve for everything on the left-hand side. And so you're gonna have, I wish that wasn't in the least convenient place on the planet. Anyway, so we're gonna have 84.6 times 215, okay? And so that will be 18,200, okay? And so I'll click down here. So we're gonna have 18,200 divided by 296.5, okay? That will come out to be 296. Please click 9.5. Okay, so this will be 61.4. Okay, so we have 61.4 is equal to 101 kPa times V2 divided by all of that divided by 273 Kelvin. Okay, so the next thing that I'm going to want to do is multiply both sides by 273. Okay, so if I multiply both sides by 273, you're going to have, you're going to get rid of 273 on this side, and then you'll have 61.4 times 273. Okay, and so you should get 16,800. So we have 16,800 is equal to 101 kPa times V2. Now all we have to do is divide both sides by 101. So we'll get 16,800 divided by 101 kPa. So you should get as your answer 166 cubic centimeters. Okay. Does anybody have any questions about how I got that? And I can put a thing here. This is going to be 16,800 divided by 101 kPa. That is going to be equal to V2. Okay. Any questions about any of this?
I have a question.
Yes.
So I got the right answer, but I did it differently. Does that matter?
Maybe once you start doing harder problems, but for the scope of this class, probably not really. How did you, I mean, obviously it might be hard to explain over this, but what different step did you do?
So instead of, I converted all the kPAs into atmospheres.
Oh, yeah, that's fine. See, so what you did right here is instead where you have standard temperature and pressure, I just took the 1 atmosphere and turned that into kPa. You took the 84.6 kPa and turned that into atmospheres, right? That's all you're saying?
I did the opposite conversion.
Yeah, it's, see, all the conversion, as long as you're working with the right converted numbers, all of your answers should come out the same. I mean, you could turn both of those into torr, and as long as you converted them right, it would be fine. I would not recommend that, but yeah, that works perfectly, Cam, however you want to do that. For me, though, it's just easy to look off that thing and say, well, 1 atmosphere is 101 kPa. So that was kind of what I was looking at. Does that make sense?
Yep.
All right, so we got the gas law, or we got the combined gas law. We got about 10 minutes, probably enough time for me to do one more with the way that this whiteboard thing works. Does anybody want to see another law specifically, or does anybody want to see a specific problem? Oh, and Anthony,
Yes.
did your mom bring that in? Are they still doing that now? Is that like sitting in a box at the school for me?
I'm not sure. She just took it in Tuesday, so
Okay.
I don't really know where it's at.
I've just been trying to avoid going to the school, but if I know I have something there, I'll run in and grab it. So I guess I can just call like Marine or Amy and see if I have anything sitting in my box. No big deal. I'm just double checking. Anyway, is there another question that you guys want to see? The Dalton's one is super easy because all you're doing is you have to make sure that they're all the same pressure. So make sure they're all either in torr, kPa, atmospheres, or millimeters of mercury, and then just add them together. That's a really easy one. Or you just have to subtract from the total to figure out one of your partial pressures, because that's Dalton's law of partial pressure.
Can you do number 20 really quick?
Oh, yeah, number which one?
20.
20, okay. Determine the molar mass of a gas that has a density of 21.8, or sorry, geez, 2.18 grams per liter at 66 degrees Celsius and 720 millimeters of mercury. Hint, the number of moles of a substance is its mass divided by its molecular mass, and mass and density is mass divided by volume. Okay. Gross, this problem sucks. So just looking at that, you're going to need to be finding molar mass, so that makes me feel like
Use the ideal gas law is what I did for this one.
yeah, that's the only one that seems to make any sense, because that's the only one that really has, I guess technically you can use molar mass during the effusion one, but that has nothing to do with effusion. So let's go ahead and whiteboard it up. All right. And again, remember, you guys didn't have to do the whole worksheet. If you wanted to, that's cool, but the main thing was just doing one with at least each of the gas laws. So we're looking for molar mass of a gas. So molar mass. Is going to be what we're looking for. Okay. Oh, that sucks. They just canceled the red ants pants. Anyway, the temperature is 66 degrees Celsius. So again, just with all temperatures, I would bump that up. So 339. Okay, so temperature is going to be equal to 339. The pressure. Sorry, I'm really slow right now, trying to work between this whiteboard and everything. 720 milligrams of mercury. Okay, so PV equals nRT. All right. We have the volume, grams per liter. Density is mass per, okay. So I guess how I would do this is we're essentially working with one, yeah, I think that's how you would do this, is work this out at 1 liter for your volume, because it's grams per liter. And so our volume, again, we're working with PV equals nRT. We don't know what N is. That is the number of moles. So PV equals nRT. Temperature, volume, let's go 1 liter. Then R, the R that we're going to want to use, we scroll up, there's a couple of different R's available to us. The R is the ideal gas constant. kPa. So we're probably going to want to change that, pressure, since millimeters of mercury is not really one of the things that's used, so we can just go ahead and switch that into atmospheres. So okay, so in 1 atmosphere there are 700 and I'm gonna have to do this on paper really fast. Sorry guys. Okay. 760. Okay, so your volume or your pressure, let's actually make that 0.94 atmospheres. Okay, so we have all those. And then the R that we're going to want to use will be, since we now have that in atmospheres, 0.0821. Okay. That's going to be liters, atmospheres divided by moles times Kelvin. Okay. All right. So we're going to have liters, atmosphere, moles. Okay, so that's everything that you'll need to use. All right. And so we know we're working at one liter, that much atmospheres, 0.94. The temperature is 339 Kelvin. All right. So let's set this up. PV. So we're going to have 0.94 ATM times the volume, which is 1 liter. Okay, it's going to be equal to N, which we are solving for, and then times 0.08. We need to extend this box out to 1 liters times atmosphere divided by moles times Kelvin. All right, and then speaking good old Kelvin, we're going to have that times 339 Kelvin. Okay, and so what I'm going to do next is we're going to have just essentially multiply everything on this side, this many atmospheres, or this many, that number is going to be equal to N times, and we'll multiply those other two numbers, 0.0821 times 339. Okay, and so that'll come out to be 27.8. Okay, now you're going to need to divide both sides by 27.8, so 0.94 divided by 27.8, okay, going to be equal to N. All right, so 0.94 divided by 27.8. Excuse me, we just went over about 1 minute on this. So you'll get N is equal to 0.0338 moles. Okay, so we have moles. Okay, and now the thing that we need to do is solve for the molar mass of this. And as it's stated on the problem, molar mass is just going to be the mass divided by the number of moles of a substance is its mass divided by molecular mass. Okay, and that's what we're looking for, is the molar mass. Okay, and so we have the number of moles. So molar mass is going to be equal to the mass divided by moles. Right? Is everybody good here? I think I'm on the right topic. I'm trying to get you guys out of here on time. And so we know that there are 2.18 grams per 0.0338 moles. And so do that. 2.18 divided by 0. Come on, 0.338. 64.5. Okay, so the molar mass is equal to 64.5 grams per mole. Okay, so that's what I get. I don't know what the answer key says. 64 grams per mole. So they just went one less thing than I did. All right. Are there any questions about this? Sorry that you guys went about 4 minutes over.
No, that explains it. I was totally off.
Okay. And like I said, I will save this video, put it up on a YouTube, and I'll send you guys the link to that YouTube channel so that way if you guys want to look at this, you can. I'm not going to give you guys any homework besides just making sure you get the stuff I sent from last week finished. On Friday, I will send out a new link for next week's stuff in terms of when or the link for our Zoom meetings for next week. We will have one on Monday, okay? All right. If nobody has any other questions, then I will let you guys go. Thank you guys for letting me go a little long. Have a good one.
You too.